In this video, we are going to learn how to use a graph or a table to solve a system of equations. Now, to start out, a system of equations is a set of two or more equations. Very simple. If you look down here, this little curly brace is known as a set, and then there are two equations in that set. So this is a system of equations. Now, more specifically, a linear system consists of linear equations. So this is a linear system because both of these equations are lines in standard form. And lastly, a solution of a system is a set of values for the variables that makes all of the equations true. So we're looking for a pair of x and y that makes both of these equations true at the same time. So where both of these would be true at the same time is where these two lines would intersect, and they would share one point in common, and that would be the solution to the system. So in order to do this, the first method we're going to try is graphing. We're going to put both of these equations in slope-intercept form. We're going to graph them and then visually see where on our graph the solution is. So first I'm going to add 3x to negative 3x plus 2y. And I'll end up getting 2y is equal to 3x plus 8. I'll divide by 2 and get 3 halves x plus 4. That gives me a slope of 3 halves and a y-intercept of 4. So on the graph, I'll go to the y-intercept of 4 and use the slope of 3 halves, which means up 3 over 2. And if I try using that point, that goes off my grid, so I'll go backwards. Down 3, back 2. Down 3, back 2. Down 3, back 2. And I should have a nice line. So now we have the line y equals 3 halves x plus 4, which comes from the standard form equation 3x plus 2y equals 8. And solving the other equation, we can get 2y is equal to negative x minus 8. Then divided by 2, y is equal to negative 1 half x minus 4. So a slope of negative 1 half and a y-intercept of 0, negative 4. So 1, 2, 3, 4. And 1 half would be down 1 over 2 for negative 1 half. Running out of space, I'll go backwards. So up 1, back 2, up 1, back 2, up 1, back 2, and so on and so forth until I can create a line through all of the points. And you'll see this one point of intersection at the coordinates 1, 2, 3, 4, so negative 4, comma, 1, 2, negative 2. So this would be the solution to the system. And the way we can check this is we can plug it into both of the original equations, but just by substituting it in. So negative 4 for x, negative 2 for y. That gives me a positive 12 plus negative 4, and that does indeed equal 8. And I can plug it into the other equation because it needs to be true for both of them. So I get negative 4 plus 2 times negative 2, which gives me negative 4 plus negative 4, which does give me a negative 8. So this is a correct solution to that system. Now, another method we can use is using a table, meaning we'll plug in values and we'll see at which x value do the y values meet. So if I were to take 0 for x and plug it into one of the equations, when I go to solve that equation, I'll get 2y is equal to 8. Give me y is equal to 4. So at 0, the green equation, negative 3x plus 2y equals 8, is equal to 4. And if I plug 0 in for x into the other equation, I get 2y equals negative 8. Divide by 2, y equals negative 4. And I can keep continuing to go through and plug in points. So again, I could plug in negative 1, And I'll get 3 plus 2y is equal to 8. 2y is equal to 5. So y would be equal to 2.5. And I could continue plugging points into this equation until I fill up my entire table. And one trick I'm using right now, instead of plugging it in over and over again, is I saw the change from one point to the next was always going down by 1.5. So I continued the pattern that way. I can also do it in the other direction as well. Now with the red equation, if I plugged in -1, I'll get -1 plus 2y is equal to -8. 2y is going to be equal to -7 because I have to add 1 to both sides. And y would equal -3.5. So it's changed by 0.5 every time. And I'm going to see I have one particular solution at -4 because that is where they both equal each other. And again, showing that solution to be -4 for x and -2 for y. So the solution to this system is -4, -2. And that is how you can use a graph or a table to solve a system of equations.